Hey guys, welcome to my session today. Thank you all for having me at this DevFest. My name is Mashoud, and today I will be speaking about Core Web Vitals. Core Web Vitals have been recently introduced by Google this year, and today we'll be trying to understand what they are and how do we go around using them and making them awesome. So, quick background about me. As introduced, my name is Mashoud, and I lead the engineering team at Sastatica.pk. This is a startup based here in Karachi, Pakistan, where I'm from. And I'm also a Google developer expert here in Web and Angular, which means, as you can see by all the different logos on the right, these are all the different community groups that I'm interacting with and speaking at or helping run, essentially. For those of you who speak in Urdu, I also do a podcast, Karachi Wala Developer, where I'm talking about tech and startups. Just me rambling. It's a micro podcast, so do check it out if that's interesting. So Core Web Vitals, what is it? Core Web Vitals is essentially the measurement for user web experience, right? And why was this created? Because if today you were to go out and start looking for a standard for measuring user experiences, you won't really find anything very standard. So effectively, the whole idea behind Core Web Vitals was that we should introduce something that will become the eventual standard so that everybody knows, all right, if we follow these things, that means our users are getting a good user experience. Now, there are normally two questions that need to be answered when we're talking about user experience. One is what to measure, and the second one is how to measure that. So take, for example, performance. If today you wanted to ask this question, like, how good is the performance of my website? Yes, there are many websites out there that will tell you how your website is performing, but no one really is following any standard. If you need to talk about what is a good time, is it 2 seconds? Is it 5 seconds? Is it 10 seconds? There's not any consensus on that. And then what are we measuring? That's also a problem. Is it the time to first byte? Is it the time something shows up on the screen? Or is it the time when DOM content loaded is called, i.e. when the browser stops loading? So we want to take a step back and really think hard in terms of user experience. What is the thing that is most important for our users? And in this particular case, performance, as we'll see, is users seeing the thing that they have come to see, right? So it would make sense to measure up till that point. But like this, it's not just about performance. There are other metrics as well. So just let's get into this and try to see and understand what Core Web Vitals are all about. So the first metric we're going to talk about is related to performance, and that is LCP, largest contentful paint. Now, right off the bat, without me explaining anything, you can understand that we're trying to measure the largest paint that's happening when your app is loading, right? And we're talking about a specific viewport, so what the user can see. I don't really care about what's underneath when he scrolls. So we're talking about specifically the viewport the user is seeing, and we're also talking about the largest paint, right? So if you just show a logo or a loading symbol, that's not enough. If you show your main banner or your main cover photo, that's when we actually stop counting the time, right? And the second thing we talked about was what, right? So how long are we counting for? In this case, we've set a standard of 2.5 seconds. That is, if you're below 2.5 seconds, you're in the good category. If you're more than that, you need improvement, or you definitely need way more improvement if you're over 4 seconds. So when you look at 2.5 seconds, you'd be wondering, that's really short. Like, I really get to see websites that fast. But we also understand that our users nowadays are super impatient. And if you're taking very long in loading your site, there is a very high chance the users will leave and they won't even wait for your content to load. Right? So having a good performing website is a key part to a good user experience. The second one is has to do with interactivity. Now, of course, when a user comes to your website, he's not just there to stare at it. He's going to interact with it. He will scroll. He will click on buttons. He will enter inputs. And we are trying to measure the first input, and specifically how slow the browser responds back when that input happens, right? That's the first input delay. This delay is measured in milliseconds, and what you want to do is keep it under 100 milliseconds. And essentially, why is it 100 milliseconds? Because under 100 milliseconds, from the user perspective, it's instant, right? They don't feel 100 milliseconds go by. But as soon as you start hitting the 200 milliseconds or 250 millisecond mark, they'll start seeing that there's a lag or there's a delay, and they might be prompted to click again or just wonders like, is it working? Is it not working? What's happening? I don't know. This is super common in mobile apps where the computing power is very limited. So we understand that all of the rendering happens on the main thread, and so does all the execution of JavaScript. So one of the issues, this particular issue normally comes if you have a lot of JavaScript being loaded at runtime. So right after loading, you start running and executing scripts and all of that stuff. And that causes the main thread to get blocked, and essentially it doesn't allow you to render or respond to events. So if you're doing anything like that, obviously we should be using a web worker or something like that, but making sure that we have the main thread free for in order to respond to the user. That's the most important part in FID. The next one is cumulative layout shift. Now, looks pretty obvious. We're talking about some layout shifts here, but what kind of layout shifts? So for that, let's have a quick look at this video here. And this is one of the things I hate about the web nowadays, that we have this dynamic content loading up and down. And in this particular case, we're supposed to click no button, but because that thing popped up, we clicked on the wrong button, right? And this is super annoying. So what we want is a consistent user experience. You would have noticed that this also happens when you're reading blog articles. So if I'm reading an article and some lazy loading image gets rendered later on, it's going to push the content down. And what that will do is it will essentially remove the stuff that was reading from the screen and will either show the image or just shift it downwards. And again, as a user experience, that's super bad because now I'm annoyed. I'm like, where the hell did my content go? So that's measured using the score of between 0 to 1. And the calculation is a little bit specific, and we can definitely check that online. But the whole point of this metric is to calculate any major shifts. So if you're hydrating like price or some buttons, that's all right. But if there's a major shift in your content, as if the whole thing is moving down, then that's something that we're trying to discourage and we're trying to avoid. So we'll be looking at how to really fix it in the coming slides. So we have looked at these 3 metrics that have been introduced under the Google Core Web Vitals, and we're trying to really see how do you make web experience better. Now, the core of this web experience is under web performance, right? Because if your web performance is good, then things like cumulative layout shift becomes less problematic because, well, there's not much stuff loading later on. And your first input delay becomes less important because, again, there's not much interaction happening. There's small bundles, small quick executions. Everything is super fast. So the focus of today's talk is essentially around web performance and how do you make sure that you deliver in the most fast manner possible and in the smallest package possible, right? So these are 2 things we'll be looking at in today's talk. Now, in order to do that properly, we need to not just see the bundle side of things or the code side of things, but we also have to go beyond that. We have to see the complete journey of right where the user starts, presses enter on their browser URL, and the browser starts loading something. What happens? What are the steps to the point where a website gets loaded? And what are some of the choke points that can come in between? So this is stuff that we want to go into in this presentation. So in order to do that, let's start with a user, right? So we take an anonymous user first, and we make that user open a browser and enter a URL, right? Whatever URL it may be, we're going to be loading a website in this browser. Now, what's the first thing that the browser does when the user presses enter? It doesn't load your website. It checks the browser cache for your website. It doesn't go to your server right away. And this is something that's, everybody knows about this. Everybody knows about the cache because we have to constantly reset the cache, apparently. But when we're thinking of development, we're not really thinking about the browser cache. Now, some of us could definitely argue that, oh, you know what, cache configuration is not done by us. That's a little bit less true now with things like service workers and app shell. But even then, right, even if you're just using the default browser cache, using the headers, that's something you can still optimize for. Normally, it's very common to see blanket policies across your whole code base. But that's something that's all right, but that may or may not pertain to your application. Stuff like your logo actually could stay in for a month or two without getting changed, right? We don't change logos every day, but your core application code should be changing every few hours. So you have to spend a little time thinking about, okay, these are my files, this is how I'm caching them, so that when the user visits my website again, they can get the most out of the cache if possible, and that will just give them a better user experience. So after the cache is checked, and let's say it's the first time the cache is in there, the browser will then move on to start resolving the DNS. And this is where it's going to go. It's going to take the domain name. It's going to try finding the server closest to you. So this is a process that browsers have optimized for. Normally takes a few milliseconds, maybe 5 to 10 milliseconds, and they get the IP of the server. The next part is connecting to the server and then getting the data from there. And that's where a huge block of our issue can happen. And that's what to do with server latency. What is server latency? It is the time taken for a server request to go over the transport network and then back again from the server, just that part. The time taken by the server is not included in this. It's just the transport time to and from the server. And this matters mainly because of where your server may be located. And if it's located closer to the user, the latency is going to be smaller. And if it's further away and there's no direct network path to it, then that's going to be obviously a slower response. Now, if you're fully optimized, this shouldn't be more than 20 or 30 or 50 milliseconds. But if it's further away or you're in a poor network connection space, then this could be a few hundred milliseconds, right? And we'll see later on how this can compound into slowing down other stuff as well, right? So you have to be particularly careful with things like this. These few hundred milliseconds may not sound like much, but they can compound into several seconds down the road. The next thing that we tend to miss out on, again, is using the latest version HTTP. Now, HTTP 2.0 has been out for several years now, and nowadays we're rolling out HTTP 3.0. Cloudflare and Google both are pushing on that. But if you're still on HTTP 1.0, then you really should consider moving to HTTP 2. And HTTP, the migration between HTTP 1 to 2 is very minimal. You don't have to do much except upgrade your server, and you immediately get benefits in terms of reduced latency and reduced protocol overhead, because all of the communication is happening in terms of streaming and the connection that is being reused for multiple files. So you don't have to connect again and again to the server. So this is super useful. And again, a very minor difference can have a larger compounding impact in the long run. Server load management is something, again, very obvious. And as a front-end developer, it's not something we're thinking about. But at the end of the day, as a front-end developer, my job is to create the best user experience, right? And since server load management can impact my user experience, that means that I'm somehow involved in it, and I should be able to find that and report that to the person responsible if needed. So server load management is usually around checking the time to first byte metric, and we'll see how we can find that in the Chrome DevTools. And essentially, it's not that hard, right? At the end of the day, you need to make sure you're monitoring your CPU and memory in order to optimize for that return call. And if you have a server too big, you're wasting resources. If you have a server too small, your time to first byte might be too long, and you might be slowing things down for your users. Now we have these two problems where you have your server load management and your server latency. And both of them can be partly resolved by using a good CDN. Now, CDNs, what they do is they take files from your server and they put them in a cache server that is closer to your user. So you don't have to worry about having servers all over the globe, and you can have them just in one part, and your files get copied over to the edge locations where the CDN is working. The second advantage that the CDN does is, and these are just the two core ones, but there are many more if you're using services like Cloudflare. But the second main one is that because now the file is being served from the cache, the user is not coming to your server. And because he's not coming to your server, you have fewer utilizations. So you can maximize your server utilization by using the cache servers across the world. And the biggest useful, so at Systematica, we also use the Cloudflare CDN, and 80% of our static requests are essentially served by the CDN. So that's a lot of load that is coming on our server that we don't have to handle, and the Cloudflare servers just handle for us, and they give us the best performance for our users. So this is where it all boils down to, right? And this is a screenshot from the network inspector in Chrome DevTools. And here you can see a detailed breakdown of what happens when a file is fetched from a server. And there are a few important things to point out. The first thing to point out over here is the total time taken, and that's just 44 milliseconds, right? So this was a relatively small file, and we fetched it pretty quickly from the server. But the more interesting thing is that if you look at what's the thing taking the most time, it's not the fact that the downloading part took time, it's the fact that the server was simply waiting, the browser was simply waiting for the server to respond. And that's the time to first byte, right? TTFB. So this was 16 milliseconds. It's not too bad, but we can see how a file that's very small can have a large impact because of time to first byte. Now, normally when we're thinking about a website running slow, we assume that it's the content download that's taking time. But as you can see here, the content download took a fraction of a millisecond, right? So it didn't really take that much time. And what actually took time was everything else. It was first queued, then it was stalled for a second, then it did the DNS lookup, connections, this, that. So these are all the things that compound together to make a request slow. I also want to point out the queuing part, right? So normally in modern browsers, you have up to 6 requests getting queued or running in parallel, and then anything after that gets queued. So if you're trying to optimize for loading, you want to, again, optimize for the view port. What are the most important requests that need to go first so that my browser can get the stuff that's most important first and then render that? I've seen this mistake happen a couple of times. So normally what we end up doing is we put in the marketing scripts in the head tag, which end up giving them priority. And what ends up happening is that our core code, our actual logic or React code or whatever we're using, ends up taking longer time to download and run, right? And we'll see again in the upcoming slides how we can improve that as well. So that was all on the server side. And as a front-end developer, you might say, okay, these are issues that I'm not responsible for. Yes, I can definitely check them and I can advise people, but these are things that I might not have direct influence over. So what can you do as a developer? So the first thing is obviously shipping smaller code bases. As we talked before, if you ship a smaller bundle, not only does it take less time to download, it also takes less time to execute in the browser. And this is especially true of mobile devices where the computing power is limited. And so there was a research done somewhere, and the time it took to process 1 MB was about 2 seconds on that particular low-end phone, right? Now that's 2 seconds the user having to wait just to do the execution part, right? So it probably took 2 or 3 seconds to download that file, then another 1 to 2 seconds to execute that file, and then the rendering continued. So that could be very disruptive for your user if it's not properly optimized. So the first technique that we can use to reduce bundle size is something called tree shaking. Now, tree shaking is nothing new. It's been around, and libraries like Webpack have adopted it, and it's part of the build tools for most applications nowadays. And the idea on its own is very simple, that we only want to package the code that we're using and leave out everything else. Makes sense, obviously. If we're shipping code that we're not even using, what's the point to the user? So in this, what it does is it actually creates this tree and it checks, okay, these are all the functions that are actually being used in your code base, and it's going to strip out everything. Now, this is less often happening with our own code and more important when it comes to using libraries. Now, one example I can share here is of Lodash. Lodash is a very famous utility library for JavaScript, and it has a 50-odd functions of utilities that it comes with. But normally, I'm using maybe 5 or 6 of them. So before, when I used to package Lodash, it would package as a complete bundle. All the 50 functions would get packaged. But now using tree shaking, I'm only including the 5 functions, and that creates a huge saving in terms of bundle size for me when I'm shipping my product. The second one is code splitting. And code splitting is all about creating those smaller chunks of your application and getting them downloaded on demand. So basically, if you have, let's say, 2 pages, and on page 1, you're using library A, and on page 2, you're using library B and C, then you don't want to download library B and C on page 1, right? But previously, what we were doing was we were creating this one large bundle that would work on page 1 and 2. But now what we're trying to do is we're using code splitting so that we can only download library A on first page and library B and C on the second page, right? And this also includes logic for our internal code base and everything else. And when you bring this together, it essentially has a major impact on what sort of bundle you're shipping to your user when you're rendering them. Now, one important part over here again, and I'll keep reiterating this, is the focus on the viewport, right? Because most of the time, especially on mobile, the viewport is really small. The screen size is very small. So it doesn't take too much effort to just optimize for the viewport. If you just want to show like an image or some text, you just focus on that part and get that rendered first, and that's where the LCP kicks in. And once that's rendered, then you could take the rest 30 seconds or 10 seconds more, downloading the rest of the page and letting the user know that, hey, this content is being loaded. And as they move through the content, it will get loaded for them and they can keep using it. So you can do code splitting on a page level as well, so that you only use that section of the page that the user can currently see. Next one up is, again, something that's more related to the server side, but our current build tools also have support for this. So we can enable our build tools to output gzipped enabled files, so zip files essentially, and that obviously has a huge impact on larger bundles. And if we enable the same thing on the server, then these zip files get served to the browser, and the browser can then have them faster. But the important thing to understand over here, that there is overhead for zipping the file, and then on the browser you have to unzip the file, right? So if you have too many small files, like you're shipping, I don't know, 100 1 KB files for some reason, then gzip is not going to be helpful for you. It actually might decrease the performance of your application. So you have to be a little bit careful when using technologies like gzip. One of my favorite things to use nowadays is Source Map Explorer. And this is a library that essentially takes your bundle and visualizes all of the things that are inside of it. So here's an example from the documentation itself, and you can see that this particular bundle has 3 files, and this is the size and the capacity of it. Now, why is this important? Because most of the times we're not realizing how big the bundles are that we're using of the libraries. And it's only when you see the visualization, you come to realize, like, there's a particular library that you don't even use that much. Maybe you use it once, and that might be taking 30% of your bundle size. So you can then go ahead and replace that with another library, or you can write something of your own as well if you really want to shave some bytes over there. So this is now also going to be integrated into Lighthouse, and Lighthouse will do recommendations for you when it sees, like, hey, maybe you're using a library that's very large and you can replace it with a smaller counterpart. So that's something we'll also see in Lighthouse coming soon. The next thing, so that was bundle sizes, right? Now we want to look at a few ways that would, again, disrupt user experience in terms of first input delay, right? So we have the file now, but we're still not able to see the code or not interact with it. So one of the important things is that HTML parsing gets blocked when external resources are being downloaded and executed. So that's something that's very important to know. And out of the external resources, JavaScript is especially important because when you download JavaScript, the execution time may be non-trivial, right? Because normally if you're downloading an SPA, so it has to set up everything, load up all the files, and then execute it and run it, right? So you have to be very careful with these two things, that you're not really overdoing, you're not having too many executions, you're keeping the main thread free so that the first input delay can happen, really, the browser can remain responsive for the user. So here's a really neat diagram that shows how to use the new attributes on the script tags, the async and the differ attributes. And what they help you do is that essentially, if you're writing some scripts, they will help defer either the downloading part or the execution part down the chain. And again, we talked about focusing on the viewport, right? So if this is not something that's important for the viewport, then, and there are many things that are not important for the viewport, right? Stuff like marketing scripts, or maybe there's a slider library that you're downloading or something fancy. You just want to show the core content, right? And you can always defer that to the end of the loading so that your main view gets rendered first and then the loading continues. So one theme that has been very active over the last few years is lazy loading content. Lazy loading is all about fetching when the browser needs it, right? When something is in the viewport, then you should download it, right? So in the past, we've been doing this with images, and normally we used JavaScript for this, but now that's part of the native browser capability. So if you visit web.dev native lazy loading, you'll find how to use that on the image tags. And basically, it's not just images, though, but we've talked about JavaScript as well. All the big frameworks nowadays, be it React or Angular or Vue.js, all of them essentially have capabilities of lazy loading so that you're only downloading the code that's needed for that particular view, right? So that's super important. So lazy loading is definitely the way to go if you want to optimize your resource usage. The final thing I want to point on is regarding CLS. And one of the things we talked about was how dynamic content is continuously shifting stuff, right? So how can we make sure that the content doesn't shift? And the solution, one of the solutions, is actually pretty straightforward, and that's just making sure that you leave enough space when you're expecting something to render in there. So in this particular example, we have a website where we will have stuff render, some images render in the middle, just like this. And what we've done is we've left some empty space in between so that when the images render, the content doesn't get shifted downwards, right? So you have to become a little bit creative when it comes to layout shifts and essentially leave these empty spots so that they can be filled in as needed whenever the content is ready and available. Another very common place where this normally happens is with ads on top of the page, right? So again, for the ads, it's again very tricky because ads might be dynamic in size and stuff like that. So you have to figure out a way to leave that space on top so that whenever the ad gets loaded, it doesn't shift everything down and essentially gives a good user experience overall. So we've learned quite a few things here, but where do we get started on all of this, right? So I've been talking about Lighthouse, I've been talking about DevTools. So Lighthouse is a tool that's made by Google as well, and it helps you analyze your website, and it works on all websites, whether it's yours or anybody else's. It's built into Chrome DevTools. And so you can simply go into the Lighthouse tab and run a test on the website. And you can run this from your own browser, or you can go on the website web.dev/measure and run it from there. And it will calculate all of these scores for you and return to you a report. And it does not only tell you the scores, but it also tells you what to fix as well. So it will tell you, okay, you're maybe shipping too much JavaScript that's not used, or maybe too much CSS that's not used, or maybe your time to first byte is too slow. Whatever that issue is, it will tell you, it will give you recommendations so you can go in and tweak stuff out. And if you're really technical and you want to get into the details, So this tool essentially provides with a very detailed interface where you can not only see how long it's taking for the files to download, but also things like how's the frame rate looking at, what's the script execution looking at, how's the GPU working, and everything else that's related, and including the other times as well, in terms of, okay, the LCP and at what point is each event being triggered. So you have a complete picture of how the web performance looks like for you. Finally, I want to give another shout to web.dev. It's an excellent resource. If you want to know more about Chrome Web Vitals, this is the place to go and check out, and there will be a lot more information on how to optimize your website for these specific metrics. That was all it from my side. Thank you all for having me, and let's make some perform websites. Thank you.